Efficiency of a transformer. By the end of this lesson, you should be able to describe the energy loss of a transformer, describe ways to improve the efficiency of a transformer, solve problems involving transformers. A transformer with a 60-watt light bulb is connected to a 2000-turn primary coil, and an identical bulb is connected to a 2000-turn secondary coil. What can you say about the brightness of the bulbs? The bulb connected to the secondary coil is dimmer. What causes the difference in the brightness of the bulbs? A transformer with a 2400-turn primary coil is connected to a 12-volt AC supply, and a 100-turn secondary coil is connected to a 12-volt bulb. What is the current flow through each coil? What is the potential difference across each coil? Mouse over the ammeters and voltmeters to take the readings. Click on each meter to record the readings. Calculate the input power and the output power of the transformer. Record the values in the table. How is the efficiency of a transformer related to the input and output power? What is the efficiency of the transformer used? Efficiency of the transformer is given by the output power divided by the input power multiplied by 100%, which is equal to IS divided by IP VP multiplied by 100%. Thus, the efficiency of the transformer used is 79.2%. What can you say about the input power and the output power? The output power is less than the input power. Since the output power is less than the input power, we say that there is a loss of energy in the transformer. What causes the energy loss? When the student touches the metal surface of a transformer, he quickly pulls his hand away. Why? The student pulled his hand away because the metal surface is hot. What causes the heat in the transformer? Long copper wires are used to make the coils in the transformer. When a current I flows through the copper wires with resistance R in time t, there is energy loss in the form of heat given by the formula E equals I squared times R times T. When current flows through the coils, the resistance of the coils causes some of the electrical energy to be converted into heat. This in turn will heat up the iron core of the transformer in the form of heat. What can we do to reduce this energy loss? To reduce the heating effect due to the resistance of the wire, low resistance, thick copper wires should be used. The transformer works when an AC voltage is applied to the primary coil. The alternating produce an alternating magnetic flux, that is, flux that continuously changes in direction. The changing magnetic flux will induce an EMF in the coil, and an induced current is produced in the core. This induced current is known as the eddy current. What effect does the eddy current produced have on the transformer core? The transformer core is made of materials which are usually good conductors. When eddy current is produced in the transformer core, the resistance of the core causes some of the electrical energy to be converted to heat. This in turn will result in energy loss. How do we reduce the heating effect due to eddy current? To reduce the heating effect, the size of eddy currents induced in the core must be reduced. To reduce eddy currents, transformer cores are made from thin sheets of metal glued together using an insulating glue. Each sheet is thus electrically insulated from its neighbors. This is called a laminated core. The high resistance in the laminated iron core will reduce the size of the eddy currents and, in turn, reduce the heat loss. The alternating current that flows in the primary coil produces an alternating magnetic flux. What effect does the alternating magnetic flux have on the transformer? The changing magnetic flux results in a changing magnetic field that continuously magnetizes and demagnetizes the iron core of the transformer. Energy is required to magnetize and demagnetize the iron core. Thus, most of the input energy is used for this process. This would result in energy loss in the transformer. How do we reduce this energy loss due to magnetization and demagnetization of the iron core? This energy loss is reduced by using a soft iron core. A soft iron core is easily magnetized and demagnetized. Energy loss in the transformer may also be due to magnetic flux leakage. Flux leakage happens when some of the magnetic flux generated by the primary coil do not pass through the secondary coil. This will reduce the EMF induced in the secondary coil, thus reducing the output power. In other words, leakage of magnetic flux means some of the input energy is lost to the surroundings. How do we reduce the leakage of magnetic flux? magnetic flux leakage can be reduced by winding the secondary coil on top of the primary coil. Complete the table by matching the causes of energy loss with the design features created to counter the power loss.